Hi everyone, we're back with a new video where we're going to go over two pretty common IC packages that you may encounter in your work. In front of us we have the Aiden Star HDMI microscope that in a past video you saw me modify to give it a larger wooden base so that it's a little bit easier to work with because the tiny aluminum base just wasn't working for me. And we have it all hooked up to a monitor so that we can see what's going on. So let's start with the QFN package. QFN stands for Quad Flat Pack No Lead, and that's exactly what it is. It's a square package here over molded plastic. This chip in particular is now obsolete, at least this Rev pre-distortion chip that we used in a past project. On the bottom side you'll see there's a ground puck and a lot of leads coming off the side. A good thing about the QFN package is that each of these leads extends to the edge, and if I can focus this correctly, you'll see a little flash of copper at the edge of the lead here, where it's been kind of trimmed off. This is helpful because it assists in sort of QCing the solder joint once this part is placed. And I can show you that with a soldered down QFN part here. So right here you can see there's a slightly smaller QFN that's been soldered down, and on the edges you'll see the solder fillets kind of come up and stick to those copper edges. Now manufacturers will state in their data sheets that that this isn't a legit way to fully prove that the part's been soldered correctly, and they actually don't recommend that this is the primary means of connection of the chip. What they really want is a good solid solder connection to be made to all the bottom leads. But it helps because the presence of a fillet there, as I showed before, will give you a good idea that the part's been soldered correctly. Of course, you can't prove that without an X-ray, but if you're hand soldering this or just prototyping, for the most part this will work for what you have to do. Now, a DFN package is a slightly different animal. I'll show you guys one right here. So this is an RF switch, and as you can see it's a plastic cover on top of a base, and if I tilt the assembly here and refocus, you're not going to see anything here because the leads don't extend to the edge of the package. They're little leads, they're little squares inside the edges of the package. So a con of this, or a negative point of this, is this package isn't verifiable. You can't verify that it's been soldered correctly with anything other than an X-ray. So that makes this part pretty difficult to troubleshoot. But I'll show you here a way that has kind of worked out for me, has had pretty good results in removing, reworking, and resoldering these sorts of packages. So the switch we have in front of us here has a couple of open circuits under the pads. I'm fairly certain it's one of these bias connections and one of these RF connections. So all we can do at this point is remove the part, touch up the leads, get a good bit of solder on them, and then reflow the part manually and press it down to make sure there's a good connection on each of the critical leads. And while we do that, I'll have this device, this part removed, and you'll be able to see what a DFN looks like on the bottom, and kind of it will be self-explanatory as to why this is a tough part to solder down and a tough part to get soldered correctly. So here I'm all set up to remove and reflow the part. I have the board on a vise, and it's raised up slightly so that I can get a soldering iron under the chip. The reason I'm doing it this way for this particular part is because the lid is a soft plastic. Hitting it with a heat gun can potentially damage that lid, so I found with this particular part it's easier to just get under it. I have the biggest tip I could find for my iron. Side note, I removed this old tip from my iron, and you can see how it's kind of like expanded and broken apart at the base. Here's what a new tip looks like. If you've let it get this bad, you're using the tip for way too long. It's not going to heat correctly, and it's just not worth it. Spend the extra couple bucks to get yourselves new tips every once in a while, unlike I've done. So now I'll tin my iron and we'll remove the part. Going to get under it right now with the iron. And another side note, this is pretty easy with a board that's as thin as the board this design is on. It's about a 50 thousandths of an inch, 50 mil thick board, so heat transfer up to the chip from the bottom when you're heating it with the iron is, it heats it up pretty readily. If you were using a 60 or 80 mil single layer board that doesn't have a lot of copper under it, it would probably be much harder to remove it this way, and you'd have to go the heat gun route. But for this particular chip or particular design, I'm fortunate to be able to do this. So I'm just going to heat this under the chip right now. See the flux bubbling, and it's off. Now this is pretty interesting. I heated it up and I've actually pulled the lid off. You could actually see the die of the switch in there. This is sort of a problem because if I mess with any of these wire bonds here, push them down or damage them, the part's not going to work. But I'll be careful, I'll heat it up again, and I'll try to get the part off without damaging it. That's pretty cool though. Switch looks cool. Alright, so we have the part off now. Now I'm not going to be able to put the part and lay it upside down because I've pulled the lid off. But let me try and show what the DFN looks like on the bottom without dropping the part. Kind of hard to see. Oh, that's a little better. Hold on. There you go. So that's a pretty good view of things. You can see that unlike the QFN part, these DFN leads don't go all the way to the edge of the board. So when you solder them, or when they're soldered down, there's really no way to QC these without an X-ray. But what I'm going to do is I'm going to clean up the board now, redress it, and reflow this part, and hopefully we'll be able to solder it down with a little more solid connection on all of these leads. So here's a view of the board with the part pulled off, and the critical leads here are the 3 RF connections and the 2 bias connections. All the rest are either no connects or hooked up to ground. They're necessary, but if there's an open circuit on one of these, it's probably not that critical since the entire package is grounded internally. So when looking at this desoldered part, or this desoldered part of the board where we've pulled the chip off, I mean, just by visual inspection, you can kind of see a solder bump on the parts that, or on the leads that we're guessing have been soldered correctly, but maybe this bias connection, which is a flatter surface with no real solder on it, maybe that was the one that was opened. So what we're going to do now, I'll clean off this board with some wick, put new solder balls on each of the important leads, and then reflow the part without the lid, very carefully. I'm going to focus on this one and this lead, since you can kind of see these are flatter than the other leads that possibly were soldered correctly before I pulled the part off. So let's get started on cleaning off this part of the board. I have my solder wick here, and first we'll just clean up the board, and then, or first wick off the solder and then clean off the leads in preparation for re-balling them. So now what I'm doing is just heating up the solder wick on top of these leads. And it's taking a little longer than I thought because this board was likely manufactured with lead-free solder, which has a way higher melting point than the standard leaded. So that's clean enough for the next step, because we don't really want to take all the solder off. We just want to get everything nice and uniform before putting more solder on top. I'm just going to clean everything up with some alcohol and lacquer thinner. A little more solder out of the middle area. So now what I'm going to do to prepare this surface for reflowing the chip, I'm going to heat it from the bottom again and take a little flux and the solder and kind of hit every one of these leads to make, with the solder, to make a nice small hump of solder on each of the leads, and pay a little bit close attention to the critical ones that need to be connected. Like I mentioned before, the 3 RF leads and the 2 bias connection leads. So let's start that now. As I start heating up the board, you'll see the flux burn off and the solder start flowing. Take a little bit of time here, but you can sort of see it happening now. See I'm going over every lead, kind of dragging the solder across. As I drag it across, you see a nice ball being formed on all the leads. And I think we're good here. So now if I were to tilt the board, let's give this a shot. Okay, you can sort of see a nice solder bump on all of the leads. So now that I have the surface prepared and cleaned, I have acceptable solder balls on the important leads. I'm going to get ready to reflow the chip. What I'm going to do now is put a very minimal amount of paste flux on the area, and I only use a small amount because, as you'll see in about a minute when I reflow the part, when the solder boils, it does it quickly and sort of violently enough that it can push the part completely off the board. So I just use a little bit just to get the solder to flow, but not boil over too much, so that the part just gets unseated and kind of flows off the board or gets really misaligned. That happens a lot. Another thing that I have to consider is, since I screwed up here and the lid popped off, I need to know what pin 1 is on this part. Luckily, the DFN packages, most of them at least, have a little marker on them on the bottom side. Let me grab this real quick, where you'll see kind of right at the bottom left by where the tweezers are grabbing it, that's your pin 1, that little triangle that they've put on the bottom. So at least with the lid off, I still know how to orient the part. So with the orientation marker, the pin 1 marker in the right position, I'll lay the part down on top and position it as best I can. and start flowing it from underneath. The good thing about flowing both QFN and DFN parts, and most parts, is that once the solder starts flowing and things get heated up, if you have a good solder mask pattern and the leads or the pads are contained in solder mask, if you position the part well enough, the part will self-align. So I'll start heating the part from underneath here. What you're going to see happen is the solder is going to start to boil very quickly. It melts way quicker than the solder. It's going to possibly move the part around a little. If I didn't put too much flux, it won't move too much, but it may require a little bit of bumping to get into place. So we'll start that now. You can see the solder or the flux boiling here, and it looks like the part's aligning itself pretty well here. Looks like I need to get a little bit more solder on my iron, a little more heat under the part. And now you can really see the solder boiling, or the flux boiling. Now, to verify that the chip has been flowed correctly, we'll just do a quick ohm check. By design, the 3 RF leads here, here, and here should read anywhere between 4 and probably 9 ohms. And each of these bias connections here should read somewhere in the 20 to 25 kilo ohm range. So let's just ohm those out right now. Top RF lead, looking at about 5 ohms. This RF lead, 5.2 ohms. And this other one, 4.8 ohms. So nice, we've verified that the RF traces are all hooked up to this chip correctly. Now onto the bias leads. We got 24.8K here, and 24.8K here. So despite the fact that the lid came off the chip, this is a fairly successful rework of this IC. I'm going to go back and replace it with a brand new one because I can't have this go out with the chip without a lid because these wire bonds can be easily damaged. But in other videos we're going to look at chip and wire assemblies like this because they're pretty cool, and there's a lot to learn about how a finished IC is put into a package and all of the steps that go on with that. So I hope you liked this video. We'll be doing more rework on different types of packages in the future, and thanks for watching.